Hello students, today we are going to see the topic extraction techniques for phyto-pharmaceuticals. In this video you are going to learn about extraction definition, what are the different terms used in extraction, what are the different closely related terms of extraction, factors affecting extraction and mechanism of extraction. So first of all, let us look at the definition of extraction. It is a process of separation of medicinally active portions of plant or any animal tissue from the inactive or inert components by using suitable solvents. So in general, if we are going to separate some of the important or desired constituents or desired compounds from medicinal plant parts like leaves, roots, stems, flowers, bark, etc. using any liquid may be water, it may be alcohol, it may be chloroform or any other organic solvent, or it may be the mixture of organic solvents. So these process of separating compounds using suitable solvent is known as extraction process. Now we are going to learn about the terms which are used in the extraction process. The first term comes is extract. Here extracts are nothing but they are the preparations or they are the end product of the extraction process, which is composed of crude drugs which contains all active components or all desired components or constituents which we get after completion of extraction process using suitable solvent. The main priority, the main prerequisite of the process is that the desired constituent which we require must be soluble in the chosen solvent. So solvent must be capable of solubilizing those desired constituents, and the crude part or the part which is obtained after extraction process is known as extract. So extract may be liquid or it may be dried extract after removal of solvent from the liquid extract. The second term which is used is known as mark. The anything which is remained after extraction process is known as mark. So mark is nothing but it is unwanted material which is solid residue remain after extraction process. The next term is known as menstruum or solvent. It is nothing but it is a liquid part which is used for solubilizing the active or desired components of the plant which we are going to use in extraction process. It may be liquid of any nature, of any polarity like water, it may be ethanol or any other organic solvents like chloroform, benzene, petroleum ether, toluene, hexane, etc. There are many solvents ranging from non-polar to polar solvents. Other closely related terms like we generally use extract, fraction and isolates frequent times in phytopharmacy, but these terms are not the same terms. These are little bit difference in these terms. Say for example extract, it means if we add water in the plant material, all the compounds which are soluble in water like glycosides, tannins, amino acids, these all comes in that the water extract, hence this is known as extract because it contains all compounds which are soluble in water. But when we are going to target a specific group of compounds like glycosides, tannins or alkaloids or any other phytopharmacy class, then we are going to use a particular solvent. Say for example we are going to use alcohol, and if we carry out extraction using alcohol, we will definitely get the compounds like glycosides or tannins separated out from the other group of compounds, and this type of the material which we get after the process is known as fraction. It contains specific type of compound rather than the mixture of compounds. That's why this process is also known as fractionation process. The other term is known as isolation or isolates. So isolates are the individual separated compounds or phytocompounds which are separated from the fraction in acceptable pure form. So say for example, if we are able to separate senoside from senna leaf powder, then senoside is known as isolated phytoconstituent. Likewise, atropine from Atropa belladonna, then quinine from cinchona. So these are known as isolate or isolated phytoconstituent because they are obtained from the plant in individual form, in the single entity form, using various extraction methods, using various isolation methods, or like using various chromatographic methods. Now what is the mechanism of extraction? This is the very basic and very simple illustration indicating that for example, here in green leaf we can say that our compound of interest are depicted in the red dots. They are molecules or compounds of interest which are present in the leaf. The leaf is known as the basic plant material or raw material, and here right side the fluid or solvent is being depicted. When they are mixed together, there will be the mechanism of extraction. The mainly will be the solubilization, and there will be the interaction between solid and liquid phase, and the liquid is going to solubilize the molecule of interest which are soluble in the solvent, and finally those solid part of leaf and the liquid part with molecule of interest is separated using simple filtration process. This is how the mechanism is involved, and the main mechanism involved in this extraction process is solubilizing, or we can say solubility. The fundamental involved is known as solubility. Now we are going to discuss about the factors affecting extraction process. The first factor is nature of drug. Why nature of drug? Because the solubility of the compound is the ultimate priority of our approach, and we must know the solubility of our desired compound. We know that senosides are soluble in alcohol, alkaloids are soluble in chloroform or benzene. Likewise, tannins are soluble in water and alcohol. So nature of drug or the solubility of the drug is the prime factor which affects the extraction process. If we don't know the solubility of our compound, we are unable to carry out extraction process. The second is solvent or the choice of solvent. According to the drug of interest which we want, according to the solubility of that compound, we are going to choose our solvent, and solvent polarity must be according to the solubility of the compound. So the second factor is solvent. The third is temperature. Rise in the temperature may lead to the increasing the rate of extraction process, but here keeping in mind we cannot increase the temperature beyond the boiling point of the solvent, and we have to also consider the sensitivity of our desired compound towards temperature, because if we increase the temperature, it may happen that our compound may be affected or may become inactive if we carry out extraction beyond the temperature. The next is solubility with pH. So solubility also depends on pH. Like example is quinine. Quinine is soluble in organic solvent at pH 7, but it is insoluble at pH acidic pH like below 7, because it can easily form salt with the acid. And the next is particle size of the raw material. As the particle size decreases, surface area of the compound surface area of the raw material increases, and if the surface area increases, the solvent is able to penetrate each and every molecule, each and every particle of the plant part, and hence the extraction process is improved. The next is authentication of plant material, because if we don't know the authentic source of the raw material, if we target our desired compound but the source is not proper, then we are not going to get our compound, or we are not going to get the success of our extraction method. Say for example, I am targeting cyanocytes to be extracted, but if I don't get the pure source of senna, then I am not going to isolate or extract cyanocyte, because cyanocytes may not be present in the other sources. The second is right plant plus right part of the plant. If I want to get cyanocyte extracted out, so I must use senna leaf and senna pods for my extraction process. If I use senna root, I will not get the cyanocyte getting out of the plant material, because root does not contain the senna. The age of the plant also is very important, because metabolism affects the production of secondary metabolites like cyanocytes or alkaloids, and if the metabolism is not up to the mark, the amount of constituent is not proper and we cannot get the compound extracted as required. The time and season and place of collection is also important, and it is also being studied by you in cultivation of medicinal plant and collection of medicinal plant. So the time mainly the time is the flowering season or the fruiting season of the plant is chosen, but it depends on the plant, and it is being greatly described by the many of the books that for a particular plant which season is the best season to collect the plant material. Grinding methods and powdering techniques are also important, because it has been studied that some of the plants will require the coarse particle size instead of fine particle size to carry out better extraction process. Example is piperine from Piper nigrum, black pepper. The quantity of menstruum is very much important, because you cannot have the equal amount of plant material and equal amount of menstruum or solvent, because it is generally seen that you have to select 5 times or 4 times more quantity of the solvent rather than the quantity of the raw material. For example, if we are going to extract 100 gram of plant material, then I have to add minimum 400 to 500 ml of solvent for the extraction process. It will ensure that each and every molecule or each and every particle of the plant material is being in close contact with the menstruum or solvent, and solubilization takes place. And the designer material or fabricator of the extractor, it greatly depends on the extractor design and the fabrication material, because sometimes this extraction process also been affected by this type of faulty design. This is all about the today's lecture. Now in next lecture we are going to discuss about different types of extraction process: maceration, percolation, Sauerland extraction, cold maceration, hot extraction methods, and so on. So I hope you find this topic interesting, and see you in the next lecture. Thank you very much.